We've talked a lot about what goes on deep within the Earth, but we haven't really taken a deep dive into the layers that create the planet that we live on. So what we see here is a 3D cartoon of the multi-layered planet, showing the three layers, which are the crust, the mantle, and the core. And we're going to talk about each of those in turn, and you'll see this image repeated over the next couple of slides. Now the crust is the part that we actually live on, the outermost part of the Earth. It's relatively thin in comparison to the other layers, and it's relatively brittle. The crust is part of the lithosphere. Now, I don't want everyone to get confused because we're talking about a couple of different systems here. We're talking about the system that contains the crust and then the mantle underneath. And in our discussion of plate tectonics, we talked about the system that contains the lithosphere and the asthenosphere underneath. They're different. The crust contains the lithosphere, but only part of it. Part of the lithosphere is also in the mantle. And this has to do with the temperature and the density of the rocks. Now, the thickness of the crust varies depending on whether you have oceanic crust or continental crust. There's two distinctly different kinds of crust. Our oceanic crust is relatively thin, only about 8 kilometers thin, and it's relatively dense, which means that it floats a bit lower in the asthenosphere. The lithospheric part of the oceanic crust floats lower in the asthenosphere than the continental crust. The continental crust, on the other hand, is a bit thicker, about 45 kilometers, but it's less dense, so it floats a little bit higher. So as we're talking about plate tectonic activity, that explains why the oceanic crust usually ends up going underneath of the continental crust whenever there is a collision. Now, as we dive a bit deeper into the Earth, we've got the mantle. We know the most about the crust, we know less about the mantle, and we know almost nothing about the core. So the mantle is in the middle. It's also the largest portion of the Earth by volume. It's mostly, from a mineralogical perspective, olivine and pyrazine. So these are very mafic rocks, a lot of iron, a lot of manganese. The asthenosphere is located mostly in the mantle. The mantle is solid, but it's very warm. The asthenosphere is the part of the mantle where the rock is near melting. So the lithosphere extends down into the mantle, but includes the part where the rocks are mostly solid. As you move down further into the mantle, the rocks actually get warmer, and eventually they get close to melting, and that's the asthenosphere. The mantle core boundary is what we call the mesosphere. So as we get really far down into that area, deep into the Earth, we've got the core. The core is the innermost layer, and it's actually two components. We have the inner core and the outer core. The inner core is actually solid. It's nickel and iron. The outer core is nickel and iron as well, but it's mostly liquid. Now this sounds counterintuitive initially. You might think that the deeper into the Earth you go, the higher the temperature, and thus we should have the liquid portion at the very center. The reason we don't is that the pressure is too high. States of matter are not only determined by temperature, they're determined by pressure as well. So the combination of temperature and pressure in the inner core does not allow for a liquid state. In the outer core, the temperature is high enough and the pressure is low enough that we do have a liquid material in the outer core. But remember, when we talk about seismic waves, some seismic waves can't pass through liquid, so the outer core actually absorbs some of that energy.